Hello everyone, I am Dr. Krishna Sarker. Here in this session, I will be going to discuss about block diagram reduction techniques. Example number 1. This is linear control systems lecture series on linear control systems lecture number 24. So our topics block diagram reduction techniques, and this is example 1. Block diagram reduction techniques. This is example 1. Find the overall transfer function C of S divided by R of S, where C of S is called controlled output and R of S is called reference input. This is Laplace transform of output divided by Laplace transform of input, and all initial conditions are zeros. So this ratio is called transfer function. What is the problem? R of S, this is reference input, and this reference input also called cause or excitation, and this is the summing point or comparator, and this direction always forward and positive. And another summing point, then G1 of S, another gain G2 of S, then again summing point, and third gain G3S, and the controlled output, this is the controlled output C of S, and this is the feedback H of 1, H1S, and this is negative feedback. Another feedback H2S, this is also negative feedback, and H3S, third feedback, this is also negative feedback. And this is figure A, our target CS by RS, that is C of S divided by R of S, control output divided by reference input by using block diagram reduction technique. So solution. Step 1, removing the feedback loop. Removing the feedback loop having feedback path transfer function H to S. That means this is the feedback path transfer function H to S. Removing the feedback loop, that means this loop. So feedback path transfer function H to S of the above figure A, and we get figure B in step 2. So step 2, again R of S, summing point, G1S, G2S, again summing point G3S, first feedback, second feedback, third feedback. This is figure A. Our target, this loop, that means this is the negative feedback control systems. So calculate transfer function. We know that the transfer function definition, G of S divided by 1 plus G of S into H of S. For negative feedback, this is positive. If positive feedback, this is negative. So calculate the transfer function. If R of S input, this is the negative feedback closed loop control systems. This is the summing point, planned gain G of S, and C of S system output or controlled output, and feedback equals to H of S. and B of S equals to primary feedback gain. This is the negative feedback. Hence, the above feedback system can be reduced to a single block shown in figure below. R of S equals to R of S reference input G of S by 1 plus G of S into H of S, and C of S equals to reference controlled output. Then CS by RS equals to transfer function GS by 1 plus GS into H of S. This is for negative feedback transfer function. C of S by R of S equals to G of S divided by 1 plus C of S into H of S. So our target, next block, solution. For solution, reference input R of S, summing point, and then again next summing point, then G1S into G2S, and for this portion, G3S by 1 plus G3S into H2S, and the output C of S, because GS equals to G of S equals to G3S and H of S equals to H2S. So our formula GS by 1 plus GS into HS, that's why G3S by 1 plus G3S into H2S. Then the negative feedback, H3S, again another negative feedback, H1S. So step 2 complete. This is our block gain, G3S by 1 plus G3S into H2S. Next, step number 3, interchanging the summing point 1 and 2, and we get, this is the summing point 1 and this is the summing point 2. Interchanging the summing point, that means this summing point this position and first summing point second position. Summing point 2 to 1 and 1 to 2 interchanging. This is the direction actually. This is the direction. So interchange the summing point. This is the R of S, positive. So this signal also positive. Again, this is the positive signal. So this is also positive. Next, G1S, G2S, G3S by 1 plus G3S into H2S, controlled output C of S, H3S, and H1S. Just interchange these two positions. Position 1, this is the position 1 summing point. This is the position 2 summing point. But the direction and sign convention same, because this is negative feedback. So this is also negative feedback. This is also negative feedback. So this is also negative feedback. So sign convention also same. This is the step number 3, interchanging the summing point 1 and 2. Then replacing the cascade block by equivalent block. Which one cascade block? G1S into G2S. This is the cascading block or series block. And G3S by 1 plus G3S into H2S. This is the feedback loop H3S and this is the feedback loop H1S. So solve this cascade block. This is the cascade block or this is the cascade block. What is the formula? For cascade rules, rules number 2, RS reference input, first block G1S, output C1S, G2S second block, and C2S output of G2S, and the G3S third block, output C of S. Then C1s by Rs equals to G1s. This is equation number 1. C2s by C1s, second block, for second block. This is G2s. This is equation number 2. And Cs by C2s, this is equivalent to G3s. Then multiplying equation 1, 2, and 3. Multiplying, this is equation number 1. This is 2. And this is the equation number 3. So equation 1, 2, and 3, we get multiplying and we get G1s, G2s, and G3s. That means C1s by Rs, C2s by C1s into Cs by C2s. So this is equivalent to Cs by Rs because C1s, C1s cancel, C2s, C2s cancel. So this is our formula. And what is the conclusion? This is the block G1s, G2s, G3s. We concluded that the cascade connection of 2, 3, or n blocks can be replaced by a single block whose transfer function is equal to product of transfer function of individual blocks. So this is our formula for cascade systems. Then solve this portion and we get product of two gain G1s into G2s, and this block G3s by 1 plus G3 into S into H2s. This is the H3s feedback. This is H1s feedback. This is the H1s feedback. Then step number 4, removing the feedback loop having feedback transfer function. TF means transfer function H1s. So R of S reference input, summing point, G1s into G2s. This is G3s, and this is the feedback H3s, and this is the feedback H1s. And removing the feedback loop having feedback path transfer function H1s. So remove this feedback H1s. And what is the definition? GS by 1 plus GS into H of S. GS into H of S. Where G of S equivalent to G1s into G2s and HS equivalent to H1s. So what is the transfer function? Again, this is our target portion, and R of S reference input. So G1s into G2s, this is the GS by 1 plus GS into H of S, because this portion G of S, this is called G of S, and this is also G of S, and this is H of S. So what is the formula? GS by 1 plus GS of HS. In this case, G1s into G2s by 1 plus G1s into G2s into H1s. Then next part, G3s by 1 plus G3s into H2s, controlled output CS, and H3s, another negative feedback loop. So these two block also again cascade operation. So this is the G1s, G2s by 1 plus G1s, G2s into H1s, and this is the G3s by 1 plus G3s into H2s. These two block cascaded. So first block into second block gain. So RS reference input. This is the comparator summing point. G1s, G2s, and G3s. This is the product, and denominator 1 plus G1s, G2s, and H1s. First block G1s, G2s, and G3 H1s. This is the first, this portion, and for this part 1 plus G3s into H2s. 1 plus G3s into H2s. This is the negative feedback H3s. So again, this is closed loop systems. So removing the feedback loop, having feedback transfer function, feedback path transfer function H3S. So which one H3S? This is the H3S feedback loop. So RS reference input, C of S controlled output, and this portion G of S. This is the G of S, total G of S system gain, and H3S feedback gain. So what is the formula? Again GS by 1 plus GS into SS. 1 plus GS into SS, where GS equals to what? GS equals to this part, and HS equals to H3S. HS equals to H3S. Then solve this equation. This part G of S, this is the G of S, divided by 1 plus G of S into H of S, H3S, H of S. And this is the output C of S. This is the output C of S. So in this case, this is the G of S, this portion. And this is also G of S. And H3S feedback gain 1 plus, and denominator part also called characteristics equation. Then what is CS by RS? Overall output, removing the feedback loop, having the feedback path, CS RS reference input, this is G of S, and this is 1 plus this portion, and CS by RS equals to just G1S, G2S, G3S by 1 plus G1S, G2S, H1S, 1 plus G3S, H2S plus G1S, G2S, G3S into H3S. This is the overall transfer function. This is the overall transfer function. Thank you.